Assalamualaikum and very good day Abid to the examiner Dr. Najmuddin Yaakob. My name is Ikmal Ramlan, a final year student from Faculty of Chemical Engineering UiTM Shah Alam. So in this video, I will be explaining on my final year research project which entitled The Determination of Critical Micelles Concentration or CMC of palm kernel oil based maltosides. Before I proceed with complex terms, definitions, and explanation, let me just briefly introduce on this project first. First and foremost, we all are aware that there are abundant of cleaning and personal care products that are available in the market, but do we know what is the key component in these products? So the key component in these products is actually surfactant. That stands for surface active agent. This surface active agent comprises of two parts, which is the hydrophilic head and hydrophobic tail. So like this figure, like this schematic diagram, the oval shape is the hydrophilic head and the string-like is the hydrophobic tail. So one of the most used surfactant nowadays is alkyl polyglycosides or APG. It is a non-ionic type of surfactant which have been used for numerous applications including cosmetics, household, and industrial. Thus, this work is using an improved surfactant type, an improved APG surfactant type, which is the palm kernel oil based maltosides or MPKO. This MPKO comprises of maltose as the sugar head and fatty alcohol as the hydrophobic tail. Going to the problem statement, even though commercialized APG coming from natural resources and poses no harm to and poses no non-toxic and no harm towards the environment, it is still poses disadvantages like stated here. For example, the chemical composition is still complex and it is in lack of hydrophilic domain. Thus, this work is using the mixture of short and long chain glycosides in improving the detergency properties. So the main objectives of this work is to determine the critical micelle concentration, CMC of PKO based maltosides, in order for us to further study on its detergency properties, and also to study the relationship between surface tension and the concentration of surfactant. But before that, what is CMC? CMC is actually the point where surfactant molecules started to form aggregates like this one. These are the surfactant molecules that are forming aggregates. For the scope of research, this work is an experimental work that applying tensiometry or surface tension method in order for us to measure the CMC value of MPKO at 30 degrees C. And then from the CMC value obtained, we compare it with the available commercialized surfactants, for example APG-C12, APG-C10, and also pure maltosides. Proceed with the methodology part of this work. So this work started with the synthesized MPKO. This synthesized MPKO was previously synthesized at Synthesis Laboratory Chemistry Department in University of Malaya. So the synthesized method was applying the Fischer glycosidation technique. From the synthesized MPKO, we have diluted into this stock solution that containing 200 mg of MPKO in 10 ml of pure water. So from this stock solution, we have made tenfold dilution in order for us to obtain series of different concentrations ranging from 0.02 gram per liter, 0.2 gram per liter, 2 gram per liter, and also 20 gram per liter of MPKO in 10 milliliter of pure water. So all of the aqueous solution, all of the MPKO aqueous solution with different concentrations are then placed in a sample vessel, glass sample vessel, which to be measure its surface tension value by using this equipment. This is KSV Sigma 702, which is suitable to measure surface tension of aqueous solutions. So this part, we have the location for the 10 milliliter sample of solution, and then the Dunoy ring will measure the surface tension of the solution. From the surface tension values obtained by using the tensiometer, a graph of surface tension versus log concentration of MPKO are then plotted like this one. As we can see, the surface tension decreases readily as the concentration of MPKO increases, and we can see that the surface tension of the solution started to stop decreasing at this point and reaching a plateau state. So this is where the CMC point that we obtain, since two linear regressions have been intercepted. After this point, based on past researcher, it stated that addition of any surfactants will only lead to wastage. Based on this graph, the CMC value obtained for MPKO at 30 degrees C was found at 0.0177 gram per liter. And referring to this table, we compare the CMC value with pure maltosites C12 and C12APG. The C12 denoted here and here is referring to the alkyl chain length, which is the carbon alkyl chain length of the surfactant at the hydrophobic part. Why do we compare it with C12 carbon alkyl chain? This is because MPKO comprises of various alkyl chains, including C12, C16, C18, C18-1, and C18-2. But the highest percentage of carbon alkyl chain is C12 with 48% based on past researcher. When comparing it with the others, the CMC value for MPKO is noticeable to be lowest amongst them. This is because El-Sukari et al. 2007 have stated that when the carbon alkyl chain when the number of carbon alkyl chain is higher, the CMC value will be lower. That means the presence of longer carbon alkyl chain in MPKO contribute to the CMC reduction of the MPKO at 30 degrees C. To sum up for this work, the results obtained from this work has confirmed the theory where sufficient amount of surfactant added to water surface of aqueous solution will make the surface tension reaches CMC point. And then second, the MPKO used in this work has presented good characteristics as a surfactant, which having a good potential for further studies. Why do I say this? This is because the CMC for MPKO is noticed to be lowest amongst the comparable surfactants. Based on past researcher, the lower the CMC value is much favorable, so that it can be used only by using low concentration, and it is more effective to use it in low concentration. And in order for us to obtain more precise data, more precise results, we have to measure the surface tension in wider range of surfactants concentration. For example, in between of 200 ppm to 500 ppm. And secondly, the recommendation that I can give is the effectiveness of surfactant can also be determined through its effect of system temperature. When there are a variety of system temperature, for example, by increasing the temperature from 30 to 50 degrees C to 70 degrees C, and then we can obtain the optimum CMC value at the optimum CMC point at different temperature. With that, I sincerely appreciate the attention and time given towards listening my presentation. Thank you.